Okay, let's talk about matrix exponential function, okay? But like, let me tell you about the truth, okay? Where basically matrix exponential function is exactly the same with the fundamental matrix, which is pi t, okay? So like, but thing is like, just like we're gonna use like different name, okay? So, but keep that in mind. Whenever you find pi t, they called matrix exponential function, and we notate by e to the at, okay? And that's it. Let's work on this problem with number 15, and everything will be clear, okay? Here we go. So process is same, okay? We're gonna find the fundamental set of solutions, and then we're gonna set the fundamental matrix, then we will solve it, okay? And that's it. Let's do it. Here we go. Eigenvalue. We need eigenvalue, and we have to set up like determinant a minus lambda I equal to 0. Let me see, like, do we have like enough space? Maybe over space. We can do it. Okay. Then my a minus lambda I matrix is 5 minus lambda minus 1, 3, and 1 minus lambda equal to 0 on determinant, right? 5 minus lambda, 1 minus lambda, and plus 3 equals 0. Distribution, 5 and minus 6 lambda plus lambda square plus 3 equal to 0. Then in order, lambda square, 6 lambda plus 8 equals 0. We can easily vector this guy, right? Lambda minus 2, lambda minus 4 equals 0. Then we have like two different real number eigenvalues, okay? Then we have to find two different eigenvector, which means like independent eigenvectors, right? Here we go. So to find eigenvector, let me take here lambda 1 first. Then we will do a minus lambda I v equals 0, right? Which is a minus lambda I, a minus 2i, then 3, negative 1, 3, negative 1, and v1, v2 equal to 0 vector. Okay, then from this guy, we can easily find the relation between v1 and v2. Okay, move to the right hand side. That's it. Then my first eigenvector is when I set like v1 equal to 1 and v2 must be 3. Okay, this is my first eigenvector. Okay, so for lambda 2 we have the same. Okay, but like with this one we can also like do like this way. And my first fundamental solution is e to the 2t and 1 3, which is 2t and 3 e to t, okay? And that's perfect, okay? Then what about the other one? For lambda 2, which is 4, a minus lambda I v equal to 0, same thing. Then it is like, you know, a minus 3 I, no, a minus 4, that's what I'm saying. 5 minus 4 is 1, and negative 1, and 3, and 1 minus 4 is negative 3, and v1, v2 equal to 0 and 0, same process, v1 minus v2 equal to 0, then I can say my v1 must be equal to v2. Then my second eigenvector is 1 comma 1. Then second element of the set of fundamental matrix is e to the 4t times 1 and 1. That is e to the 4t and e to the 4t. Then we can easily set up the fundamental matrix psi. Then psi t is equal to e to the 2t, 3 e to the t, e 4t, and e to the 4t, right? Now we're going to try to plug in 0. Then, since this is exponential function, everything will be 1, okay? Then we need the inverse of this guy, right? Is 1 over determinant and switch and opposite, which is equal to negative 1/2, positive 1/2, a positive 3/2, and negative 1/2. Are you with me so far? Okay. So now we need to find the fundamental matrix for initial value problem, which is pi, right? Here we go. Then pi t is equal to psi t times, well, like, also, like, in this section, as I told you, like, this pi t can be noted by e to the a t form, which named the matrix exponential function. Okay, again, they are same. Okay, it can be found like this way: psi t times, let me rewrite this. Okay, psi t times psi of 0 inverse, right, which is equal to e to the 2t, e to the 4t, and 3 e to the 2t, e to the 4t, and negative 1/2, 1/2, 3/2, and negative 1/2. Okay, product matrices. Okay, it is equal to negative 1/2 plus 3/2, right? And then 1/2 minus 1/2, 14, and negative 3/2 plus 3/2, 14, and 3/2, negative 1/2, 14. Okay, and now we set up like this is like my fundamental matrix or the matrix exponential function, right? Then what is my solution? Solution is equal to pi x0, or with the matrix exponential function times initial condition, right? Which is equal to 2t plus 4t, 1/2 e to the 2t minus 1/2 e to the 4t, and negative 3/2 e to the 2t plus 3/2 e to the 4t, and 3/2 e to the 2t minus 1/2 e to the 4t times the initial condition, which is 2 and 2. Okay, that is equal to negative e to the 2t plus 3 4t plus 2t minus e to the 4t, and negative 3 2t plus 3 4t plus 3 2t minus e to the 4t, which is equal to, okay, let me simplify, and this guy is gone, and this guy is also gone, right? So my solution is 2 e to the 4t and 2 e to the 4t. That's it.